Welcome back everyone and happy Thursday. So today we are going to focus on adding and subtracting with scientific notation. Before we begin, please make sure that you've gone back to last night's homework and double checked your answers with the teacher key provided on OneNote. If you have done that, then you are ready to start this lesson. So adding and subtracting is a little bit more complex than multiplying and dividing with scientific notation. The reason for that is because there are some additional rules that you need to keep in mind before you start working. So adding and subtracting, it's similar to when you were adding and subtracting with fractions. In fractions, you had to always make sure you had a common denominator. And when we say common, we mean that we want the denominator to be the same. So an example is in 5th and 6th grade, if you had 2 over 3 plus 1/2, you were unable to complete this problem. In order to do this, your teacher told you that you had to get the 3 and the 2 to be the same. So we had to find a multiple that was common, and then we had to figure out how we were going to convert into equivalent fractions. So when you are adding and subtracting with scientific notation, you are going to work it out similarly, in the sense that you have to have a common exponent. So in order to do that, we're going to start off easy and kind of ramp up levels of complexity. You guys know that I like to work this way. So let's take a look at number 1. We're just going to start with adding and then we'll move into subtracting. So for number 1, you want to start by focusing on identifying your exponent. In this case, my exponent is 3 and another 3. Because they are common, all we're going to do is we are going to add our first factor, which is 4 and 3. So this is 4 plus 3 giving you 7 as your new first factor. Because this is scientific notation, you are still keeping this times 10 format. And this time, instead of doing anything with your exponent, you are going to simply keep it common. And this problem is now complete. So let's go ahead and take a look at problem number 2. And this time in identifying the exponents, we have an exponent of 2 and we have an exponent of 4. Because we're looking for this to be common, there are different ways that you can do this. And if you go on YouTube or Google and you look up this topic, different teachers can work them different ways. But the one recommended way to minimize the amount of work that you have is to always take your smaller exponent and match it to the larger one. In this case, our smaller exponent is going to be the 2. So now you have to ask yourself, how am I going to turn the 2 into a 4? And we do this by adding. So 2 plus 2 is going to be 4. Now, you've heard me say that when we're adding spaces or taking away spaces, you have to actually move the decimal point on your first factor. So if I'm adding 2 to 9, your 9 has a decimal behind it, and in adding 2, we are going to move 2 additional spaces. So your new first factor is 0.09. Now this is times 10 to the 4th power plus the 1 times 10 to the 4th power. Now we go back just like problem number 1. You say to yourself, is the exponent the same? If the exponent is the same, we are just going to add our first factor. So this is 1.09 times 10. And of course, we're going to keep our exponent common. All right, let's take a look at number 3. Hopefully I'm not making anybody dizzy here. Let's go ahead and look at our exponents. And identifying our exponents, I have a 6 and I have a 7. The smaller exponent is the 6, so in order to turn that into the 7, I'm going to be adding 1 decimal place, turning this from an 8.0, moving the decimal 1 space to the left. So this is 0.8 times 10 to the 7th plus 3.2 times 10 to the 7th, and we're just keeping that second one the same. So now that my exponents match, we're simply going to add, right? And when we're adding here, this is when you're able to use your calculator to double check your work if you need to. So 4 times 10, and keep your exponent, a common exponent. So we're going to keep that exponent of 7. So number 4 is where it gets to get, it starts to become a little bit trickier. And that really is just because of a proficiency with integers. So on these, I'm still identifying my exponents, but now you have to think a little bit more carefully. -3 versus -4, which one is going to be the smaller one and which one is the larger one? So our larger number is -3, so the -4 is the one that I want to change. In order to do that, I'm going to take the -4 to turn it into -3. I'm going to add 1. So I'm taking this decimal, I'm adding 1 space. So this is 0.344 times 10 to the -3rd power. I'm just going to drop down my first scientific notation. Excuse me while I write kind of backwards to fill that in. Okay. And now that I have that, I go back to my exponent. Same procedure every time, and ask yourself, is the exponent the same? Or are the exponents the same? And if they are, then we're just going to add up our first factor. You have calculators, so I expect that you use those calculators. Remember that if you choose not to use a calculator, what you are going to do is you are going to line up your decimal points before you add and write them vertically. So your answer would be 1.664 and times 10 to the -3rd power. Again, remember that it's important that you keep your exponent common for your final answers. So that is adding in scientific notation. Now subtracting is going to be done the same way, but we're going to take a pause here. So take a moment right now with these 4 examples, go into your packet, and complete a few before you look into subtracting with scientific notation.